The last thing that we're going to look at in this unit is kind of something we've already been dealing with, but we haven't explicitly defined this. And it's called the conjugate root theorem, and it just helps us bridge together some kinds of solutions here. Okay, so what the conjugate root theorem is saying is that if we have an irrational zero, so a plus root b, so if a plus root b is a solution or a zero, okay, again, that could even be an x-intercept because those are real, that automatically means that a minus root b is also a solution. So these types of answers occur in pairs. Okay, and that's a direct product of basically the quadratic formula, or us taking square roots, right? Think about the answers I just got in the warm-up with the quad formula, right? That numerator, we got that value of b plus or minus the square root. Those will always occur in pairs. And again, it's because of us square rooting a value and the fact that a square root can be plus or minus. The same thing is also true for imaginary solutions. If we have an imaginary solution in the form of a plus bi, that automatically tells me that a minus bi is also a solution. So that's the connection that we need to make. And what's going to happen with a lot of these questions, to see if you kind of understand this theorem, is it'll give you one of these pairs, and you'll have to assume the second pair is also an answer. Okay, so there's really no hint that says, hey, there's an extra pair out there. We just have to recognize, hey, this is a square root that's going to occur in a pair where we have plus or minus, or the imaginary. You might get one imaginary solution, and we have to make the connection that is plus or minus. Okay, so part of what we're going to do is just recognize a conjugate pair, but then we're going to also take the conjugate pairs and write equations in factored forms that have those solutions, and that's where the work gets a little bit messy. Conjugate pairs do have different uses in other areas of algebra, so next year when you move on to pre-calc, this will show up again. Okay, conjugate pairs, I don't know that we'll see them again in this. Actually, we might see them in the rational unit next, but you definitely work with these a little bit more in pre-calc, okay, than you do in here. All right, so again, one question that we might see is it says, if square root of 2 is a solution and 1 plus I is a solution, or a zero, then what are the other two solutions, or the other two zeros? This is having you recognize we have a square root solution, and that's going to occur in a pair that if I have positive root 2, that means negative root 2 is also a solution. Same thing with the other answer of 1 plus I. If we know 1 plus I is a solution, that automatically means that 1 minus I is also a solution. So notice where that sign is changing, right? It's not the entire term that I'm changing the sign for. It's just the value either in front of, or the sign in front of the imaginary term, or the square root term. So that one's still positive, but the I became negative. All right, and here's where we're going to get some of the work to be a little ugly, because now we see four solutions, right? 2 negative root 2, 1 plus I, 1 minus I, and we're going to work to write a 4-3 polynomial with those zeros. Now, I'm not going to have us multiply everything out. We will leave it in factored form for the most part. We're going to leave it in factored form where we don't have the square root terms in there or the imaginary terms in there. Okay, and this is the skill that we've done before, but now it's just going to get a little bit more complicated with what needs multiplied. All right, so again, when we are given solutions or zeros, I just start with x equaling those zeros or those solutions. So x equals root 2, x equals negative root 2, x equals 1 plus I, and x equals 1 minus I. Okay, so those are the four zeros, or the four solutions. And I know that I get solutions from factors, right? And we set factors equal to 0 to get solutions. So what I'm going to do is work to get the right side to be 0 by subtracting root 2, giving me a factor of x minus root 2. And then adding root 2 makes that right side 0, giving me a factor of x plus root 2. for these solutions that are imaginary, I have to subtract two terms. I have to subtract the 1 and the I. So that's x minus 1. Ah, dang it. Let's see, how can I fix this? X minus 1 minus I. Again, with this answer, I have to subtract 1 and add I. So that's x minus 1 plus I. Okay, so at the very least, okay, again, let's kind of look ahead at testing here. This, again, there's going to be a question like this on the test. Okay, what parts, where can we get partial credit? If you can get to here, you're getting points. Okay, you have identified the zeros. You've been able to convert them into a form that is factored. But what's going to happen next is most of the algebra, and this is where most mistakes are going to happen, because now we're going to multiply the terms that are conjugate pairs. And when we do that, we're going to get rid of all the square roots and all the imaginary terms. Okay, and this multiplication does get it a little bit complicated. But if you can at least get to here, again, you're getting points. Okay, and this is a point that, or a place where everybody should be able to get to. Now for the multiplication. These two terms, multiplying x minus root 2 and x plus root 2, that's just foiling, so there's nothing too complex there. Multiplying these, it's a lot more complex. Okay, so we'll probably use a box to help us with that because there's so much that needs to be multiplied there. All right, so let's multiply these first. Again, I got a FOIL, so I'm going to do x times x to get x squared. I'm going to do x plus, or x times root 2 to get x root 2. And I have negative root 2 times x, so negative x root 2. And then this last term, I have a negative root 2 times a positive root 2. So that's definitely negative. Negative times a positive is negative. But then I have root 2 times itself. Root 2 times itself is the same thing as root 2 squared. Well, when I have a square root, making this x squared, positive x root 2 and negative x root 2, those are like terms, and they cancel, right? If I have one of them and I take one away, they cancel themselves out. Then I have minus, the squaring and the square root cancel, so just minus 2. So that's one of the factors here. And I can easily see that if I were to solve this, if I set that equal to 0, I would add 2 and take the square root, giving me solutions of plus or minus the square root of 2. So there's always a checking part that you can do here. Okay, does this factor make sense to give me those solutions? And you can set it equal to 0 and try it out yourself. All right, so any questions there? Because the next part gets a little more complicated. Okay, I think our best way to multiply these here, again, is using that area model. So let's set up what that would look like, because we have 3 different terms being multiplied by 3 terms. So we end up getting, if we use this area model, there's 9 different things that need to be multiplied. Or 9 different terms we're going to end up with, I guess is what I should say. So we're going to make a big box that has 9 squares. Organize and make sure that we're multiplying the terms correctly. So I'm going to take one of these factors and I'm going to let it be the outsides or the dimensions either up top or down the side, and it doesn't matter what goes along the top or what goes down the sides. And x minus 1 plus I. All right, so first, x times x, that's x squared. It's not too bad. X times negative 1 is negative x. X times negative I is negative ix. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times negative I is positive I. I times x is positive ix. I times -1 is negative I. And then this last term, I have a positive times a negative, so it's definitely negative. But then I have an I times an I, which is I squared, which brings in one more new concept with what I is and what imaginary numbers are and what happens when we square them. So remember that I is equal to the square root of -1. Well, when I square that, what cancels? The squaring and the square root, just like what we saw up here with the root 2 squared. So what this ends up telling me is that I squared is equal to just -1. And again, that's not something at this point I've done enough where I memorize it, but if you just remember that I equals root -1, you can figure this out by just squaring both sides. And when you square both sides, you get -1. So what that tells me is I squared is -1, so this is really negative times -1, which is +1. Okay, at least that bottom right square is. So what ends up happening here and why conjugate pairs are so useful in algebra is we get the imaginary terms to cancel themselves out. Because I have a positive ix and a negative ix. I have a negative I and a positive I. And so now I just need to combine the like terms that are left over. X squared does not have any other terms to combine with. Negative x and negative x is -2x. Then I have 1 plus another 1, which is 2. And this is the final factored form for where I want us to get to. Okay, so like I said, I didn't do anything new up here. Okay, I introduced 2 new concepts, the conjugate root pairs and what I squared is equal to. The rest of it is just multiplying terms. Yes, mixing in an I with variables makes it a little complex. It's just going to take some practice. Now again, before we do a couple more things together with this, any questions with how I'm getting any of these terms up here? All right. You don't need to use the box if you don't want to. In fact, on the homework, on my answer key, I didn't use boxes. I think it's really useful for where you were at with your skill set because of how organized it keeps your work and makes sure that you're multiplying all the terms that need to get multiplied. Okay? All right. So we'll probably only have time for one of these, but that's okay. So let's walk through kind of what this is communicating to us and then have you do the multiplying here. So it says, what is a third degree polynomial? That's helpful. That tells me that there should be 3 solutions and the final degree should be 3. Function where y equals p of x with rational coefficients. Those are just kind of fancy words to say that this is a polynomial function that has whole number coefficients. Okay, it doesn't really tell me to do anything math-wise. So that we have our polynomial equal to 0. That's communicating that we have solutions or zeros or roots that are 4 and 2i. So what I would start with is that x equals 4 is a solution. X equals 2i is a solution. So I'm like, okay, it's third degree polynomial. I should have 3 solutions. I can't just make one of these have a multiplicity of 2. So I'm like, okay, well, what else could be missing here? Oh yeah, if I have an imaginary solution that occurs in a pair. So having 2i as a solution automatically tells me that -2i is also a solution. That's that conjugate root theorem at work there. Now I have 3 solutions. And what I want you to do is figure out this polynomial in factored form. This factor won't need to get multiplied. You can just leave it as whatever you get from that factor. But I want you to multiply these 2 factors out. Okay, and it won't be as nasty as the one I just did. All right, go ahead and do that real quick. Should take you just a couple minutes. And that might be the last thing we get to today. Multiplying wise, this definitely isn't as complex as what we had just worked through, right? I didn't need to multiply a expression with 3 terms with another term that has 3 expressions. So area model not necessary here. Again, unless it helps you keep everything organized and keep using those area models. So the x equals 4 gives me a factor of x minus 4. Again, I don't want you multiplying anything with that. What we're going to always multiply together in here are the conjugate pair factors. So the x minus 2i and the x plus 2i. When I do that, x times x is x squared. X times 2i is 2ix. Negative 2i times x is negative 2ix. And I have negative 2i times positive 2i, giving me negative 4i squared. That takes a little bit of thought because you have to know that I squared is negative 1. So really it's negative 4 times I squared, which is negative 4 times negative 1, which is positive 4. Again, after you multiply and you're like, hey, I get positive 4 there, but I don't know if that's correct. You can check this work here. If I set x squared plus 4 equal to 0 and I solve, I would subtract 4 and take the square root. And the square root of negative 4, every time we square it is plus or minus. We can't square root a negative, so it's imaginary. And then the square root of 4 is 2, giving me plus or minus I2 or 2i. Okay, it doesn't matter what term or what part you write first. Okay, so getting those exact answers that I was hoping to get. Okay,